Welcome to a new unit on thermochemistry. This is the chemistry of energy. Now we know that in a chemical reaction, you have to break the bonds of the reactants in order to take those atoms and rearrange them and make new bonds on the product side. All of that is accompanied by some kind of an energy change, which is what we want to look at the first half of this unit. A collision theory states that bonds are broken and or formed when reactant particles collide with enough energy and with correct orientation. So first thing that has to happen in a chemical reaction is that we got to break apart the bonds on the reactant side so that eventually we can rearrange the atoms and form new bonds on the product side. And yeah, a lot of that involves atoms, molecules, particles colliding with each other. But not all collisions result in a chemical change. There are two rules of a successful collision, and they are that the particles must collide with sufficient energy and proper orientation. So for example, if I have two particles that collide with insufficient energy, there may not be a chemical change that occurs because I don't have enough energy to break apart the bonds on the reactant side. If I don't have enough energy to break apart the bonds on the reactant side, then I really can't rearrange those atoms and form any new bonds on the product side. We also need atoms or molecules to collide with proper orientation. Now, often that might mean that in a particle such as these guys, maybe this light blue atom has like a partial negative charge. And maybe this red atom is partially positive. Well, I might want those particles to collide in an orientation that would be likely where opposite charges attract. But if I have those particles oriented so that partial negative would be next to a partial negative, then it's unlikely that the particles will collide. They would repel from each other, right? So we need our particles to collide in the right orientation with sufficient energy. And when that does happen, we have enough energy, right orientation to break the bonds on the reactant side and get ready to make new bonds on the product side. Now, as this process is happening, the atoms are kind of in limbo where they're starting to break their original bonds and maybe thinking about forming some new bonds. And as this process is occurring, we say that the atoms are in an activated complex. Activated complex is really just that, where we had sufficient energy to break the bonds on the reactant side, and we're in the process of aligning the atoms to form new bonds on the product side. Now, in this question 3, it says the collision that forms an activated complex is like passing a baton in a relay race. The complex has partial bonds between atoms, and we're just kind of getting ready to form those new or more stable bonds on the product side. We want to relate electron sharing in an activated complex to the passing of a baton. And I could think of it in a couple ways. Number one, I have to pass the baton with proper orientation. I got to get it in the hand correctly of my teammate. Maybe I have to have sufficient energy. I got to toss the baton in their hand like I mean it, so they have a good chance of gripping it properly. I don't want them to drop it if I just kind of toss the baton in their hand with not enough energy. And yeah, while we're in the process of transferring the baton, there may be moments of slight instability. This activated complex is not stable. We're just starting to rearrange the atoms to form the new bonds on the product side. But when my partner finally grabs a good hold on that baton, that's maybe like forming the new bonds on the product side. I have something that's stable and ready to go.